Hello. Uh, hi everyone. My name is Krishna, and I have been working with Pratik, another engineer on our team. And we work on Velox, but we have been working over the last 1 or 2 months to increase the efficiency of open source contributions to Velox. And if you've been working over the past any number of months, then you might have noticed some changes over the last couple of months that have hopefully made things a bit better. And we will continue to work on this to make things better as we move towards GitHub first. So I think a few months ago, if you were like trying to contribute to Velox, if you made any change, you would see CI signals take a long time. Like it would take 2 hours plus. Like 128 minutes was our longest. On an average, it was always end at more than 2 hours. And then you would have test run for 45 minutes. And if you had failures, you had to like go through a sea of logs. And it's all considered very normal, and but it wasn't the best dev experience. And before moving to GitHub first, we wanted to make that better because with GitHub first, we wanted more meta engineers, especially to have lesser friction when using Git and OSS workflows compared to internal. Right. So we concentrated on like making things faster, reducing the PR turnaround, getting signals faster to you, making them more greener in the sense that you see less red, more green, and less flaky signals, less, when something's red, you said something wrong, you have to look into it, right? And then making it more smarter. So if something is wrong, it tells you, hey, this is what's wrong, go fix it, right? So I'll be just covering stuff like that now. So to start off with, like, if any of you have contributed, like, these are like the biggest jobs that we used to run on the CI, and Ubuntu debug was the one that would take like 2 hours plus. We reduced that to 53, and in fact, it's better than 53 right now. It's around 40 odd. Fedora debug also, it went from more than an hour to like 35 and less. Adapters, which is the big job that I think most OSS folks are interested in, which runs the whole gamut of S3 and hopefully OCI, as the last gentleman was talking about in the future. All of that is reduced to like 30 minutes. And our test used to run 45 plus minutes, and I'll talk about what I mean by test groups, that went from like 20 minutes to 13, 14 minutes. So we did a significant work to like reduce the time, make sure to get signals faster. So how did we go about doing that? So first thing we did was we measured per file timings on the EC2 runners for our actual file. So we used to run all the tests sequentially. Like you'd submit a job, we'll build everything sequentially, then C-test would go and run every test sequentially. And that is like really slow. Even if you try to parallelize it, it doesn't scale well or something. So what we did was we measured per file and we bin packed them into groups so that we could parallelize and run these tests across workers and like get a speed up. With the bin packing, we were smart about bin packing, so we didn't have any skews on certain end, and so with that kind of bin packing, we were able to get the test runs from like 45 minutes, which is take, to is now less than under 20 minutes, like for 15 to 70, something around that. So that created a huge speed up. We also run fuzzers. We were doing like a full build to run all our fuzzers. We had like 14 fuzzers right now, and we would do like the whole Velox build, which would come, in case you don't know, we have 550 targets when you build Velox. And so these 550 targets, like you don't need 500 of those targets when you build fuzzers. So we just build those fuzzers, ship the fuzzers out to like their own workers, and we run those instances. All these fuzzers link against libvelox, which is a shared library that we create. We also tuned the workers. We went to bigger workers, but we also tuned it. So apart from just using bin packing. And we also did some source for code rebalancing, like certain tests, for example, the index lookup join test by itself would take up 15 minutes plus, like almost 1,000 seconds to run it. We split that up and then refactored that so that we could parallelize that better. So with all this, we were able to like get, improvements in speed up. It came at some cost. So like I said, we had to group test binaries. In case if you don't know, like 500, like the actual Velox output is that most people are interested is just libvelox that's shared object in OSS. That's just one. Every other target is either a benchmark or a test case or a fuzzer binary. Um, so it doesn't, the model that Meta internally follows, where we use Buck, we encourage use creating targets and small targets and all that. That works internally in Meta because of the infra and the scale we have to handle these kind of things, and because we don't have shared linking inside our infra, we use static. But on OSS, that's like not good at all. It like slows things out considerably. Each time you create a target binary, you end up writing almost half a gig executable, right? So over 500 targets, that's like 20, 30 gigabytes just binary executables, where the static code is like just replicated n number of times. So to deal with all that, we group the test binaries. You collapse the binaries into it. So doing that, you lose some level of, you can't target certain egg texts, so you have to which is fine. I think when you're submitting CI, like you mostly ensure like you run all the tests. So I think that was like a trade-off. If you don't want it, you can set the group test to off, and then you can target some specific test that you want to run. And like I said, we had targeted fuzzer builds. Also, we did a lot of improvements. Your CI runs on these Docker images where, we didn't have that much discipline going ahead. Like you would, like people would download dependencies and stuff like that. And we actively tested that out because we wanted to ensure that that part of code was well tested. But that creates a lot of flaky builds. And going to GitHub, we want to make stuff green, so that means reduce flakiness and increase reliability. So now we have containers that have everything baked in, and so that has made things much more reliable at the but there's a cost in place. You have to the build step of the image is more. So if you are changing dependencies, that's a cost you pay upfront, but that's just one time. And then also system depends. So like I said, we just switched to system from bundle dependencies. Bundle means you pull in stuff from the internet to build stuff, and we don't do that as much on CI anymore. So all of these changes, got us like a 60% reduction in build times and test times, which is significant. And then some work that Pratik is also doing is going to bring that up much, much more. So our goal is to get it to building on your local dev machine or as close to that as possible, so that you get really quick signals. And the second part is making stuff greener, right? So when I say green, what I mean is no more, less reds. Unless you're pushing out code that is wrong, or we don't want to do that. We don't want people to get bad signals or have flaky signals, right? If our signals are flaky 30% of the time, you get into the habit of ignoring the red signals, and we don't want folks to do that. A red means, yes, something is absolutely broken. You need to go check it out. So we added flaky test retries with JUnit XMLs that capture the flaky test part, and then we have the first run that's very aggressive, and on failures we rerun the failure to figure out the flakiness, and it's really flaky. Flaky tests would show up as yellow warnings and not red failures, and then we follow up with the authors to try and get those fixed. We also have structured failure reporting, so G-test assertions will land as a PR comment and a GitHub. You don't have to go through all your thousands of lines of log to figure out what failed. It's very frustrating to go through those whole set of log, find out which particular test failed in Velox exec text, because that's pretty long. We did a lot of work to kill the fuzzer crash failure false alarms, because we increased the parallelism of CI. A lot of that work was done by Pratik in figuring out why those fuzzers failed. So much thanks to that. And in that, we've deterred, a lot of the hard-coded timeouts we had caused these issues. Like we resolved table evolution fuzzers, 10-second timeout, reduced that problem, raised the Presto request timeout for our window join aggregation fuzzers. So all these changes like help reduce 40% of like our fuzzer failures. Fuzzer failures were used to account for like a large percentage of the flakiness and other red signals we get, and we have brought that down considerably. It's still not below to the level where we'd like. We wanted to get have fuzzer flakiness below 5%. It's around 10% right now, so we're still working on improving that. So, but this reliability has made sure that, like, if you see a red signal, it's very likely something you caused. So, you have to look in. It's a better signal for you to go look into and fix stuff. So once you get the signal, so some of the some other stuff. So it's just not like fixing fuzzer bugs or like fuzzer infra bugs. Like we also found real correctness issues. Like one of the issues that Pratik found was that like there was a file descriptor bug that we found, which had about like a 0.75% flakiness rating, and that was because root cause was that there was a member region isolation order bug, which closed stdin during a test. And then glog would grab that same stdin file descriptor 0, and then it would write it out, and that would cause this corruption in the fuzzer that would come out and it would fail. And it was not something, and we struggled to replicate it until we used, spent like a day or two with Claude and like finally figure out that bug. So that was pretty cool. He discovered several bugs that he fixed, like make timestamp off by 1, where we had like wrong timestamp, where timestamp values could be 24 hours and like 60 minutes, which is wrong. Some optimizations where we were like datetime format was being recompiled per row, which made things slow, and so that also like improved stuff. So in process of making stuff greener, we actually fixed quite a few correctness bugs also, and also made the signal better. Also, and the next section I want to talk about is making things smarter. So with AI, Claude, and stuff like that, we rolled out the ability for folks to actually call upon Claude for code reviews and comments and questions inside our CI. We restricted it to meta engineers, but we are going to allow all committers to Velox to have this capability. So if you are like a committer to Velox, you could invoke Claude, and then ask questions or like ask it to do code reviews and stuff like that. So I think this is pretty useful, and it gives us feedback sooner. We are trying to also incorporate this, with the proliferation of Claude and these AI tools and the PRs that AI-assisted PRs we're getting. I think we have to set roadblocks to ensure that, the code reviews we get have some minimum level of bar rather than, having the burden of PR reviews fall upon like just the maintainer. So that's the next step that we'll be working on. So apart from that, we also did some really cool work on like the nature of your build. So build impact analysis lets you to know how targeted your change is. If you're making like a change to like type.h or something fundamental, you can see that your change is going to affect like almost every binary that we create, like 500 or something, and how fundamental that change is and how careful you have to be when making that change. And we do that using CMX file API gives us the file to target mapping and allows us to figure out like all the changes that you make in your PR, how it affects and which are the source targets that is going to come. And based on that, we can, we just added the build impact analysis, but we're going to use this to drive builds in the future so that we just build the targeted, the targets that are affected by our code change and make sure like they build and the tests succeed. so that you get much quicker feedback rather than running the whole CI, building every target, running all further. So we expect that to like reduce the turnaround time very significantly. And the other cool thing we also added is the CI failure analyzer, which allows us to, which you should have seen if you have been running, submitting code. If you see any CI fail in your job, like this workflow runs and it tells you what failed, why it failed, whether it was due to your changes or whether it's a pre-existing issue, and also gives you suggestions on how to fix it, which I think is pretty useful, and it's auto triggered. So that I think that has been well received by the community. So all of these changes, the net effect is that if we expect PR feedback in like, you get PR feedback on your PR in half the time in respect to signals. Red status means something is wrong with the PR. You have to fix it. Like, it's not something you can ignore. Failure, cause, fix, and suggestions will land as a PR community. We'll try to help you with your PR and let you know why it broke and how you can go fix it. And we'll also add, certain sort of automated PR reviews to make sure it meets a minimum bar of our PRs. For maintainers, you have to do, you have to do less drudgery in looking up logs and explaining to folks why it failed or whether the failure was legitimate. So you can, more hands-off for the maintainers, and they have to like actually look at, do more real work rather than log archaeology. They get an estimate on the impact of the particular change. It's hard to quantify impact, but at least you get an idea of like how dangerous some change can be. And then again, faster feedback for the maintainers too. So with next, we're going to add more failure analysis coverage and more Velox specific review skills, and also add faster builds and faster build, so that you get on your PRs, you get much quicker feedback on what happens next. So all this has been leading, like I said, to because we want to do GitHub first. With GitHub first, like right now, for those who know, like the source of truth is inside Meta's FB code. Like we import stuff and then lands in Meta, and then it's exported externally and merged there. With GitHub first, this order will reverse, and GitHub becomes the source of truth. Once we get there, we plan to get there soon, but we're still working on stuff. But for OSS folks, for external contributors, your workflow would still remain the same. Essentially, before you merge, though, before you get the power, what would happen if you went to GitHub first is you'd get the button saying, yeah, click, you can merge in GitHub. But before that happens, there will be another workflow that runs that validates it and pulls in your code again, and we run some sort of backwards compatibility check and further analysis to make sure it's good. And then if that fails, you would get some sort of signal saying, hey, why it failed. Whether it's like a backwards compatibility failure or test or build or something like that. We can't, some of that will be sort of like restricted, like we might not be able to give you stack traces and stuff like that, but we'll give you the general nature, and we'll have somebody work with you to fix that. And the reason why we do that, since it's C++ and our APIs are still not that well defined, we're hoping this is like the first step we can use to like make it GitHub first, and then slowly work on locking things down so that we can completely make it GitHub first and eventually get rid of this step. But apart from that, it should all be the same, and merge timing should be similar. And if, like I said, it's coming relatively soon. And if you have questions, you should feel to reach out to me, Pedro, Rohit. And yeah, so that's all the work we have been doing on the CI build side. I hope like it's been useful to the contributors, and we welcome suggestions, and we want to increase the velocity of contributors and the contributions coming into Velox. So again, thank you for all your help and efforts.